Hello viewers, in this video we are going to discuss finding equivalent resistance of infinite ladder network. Means the circuit consists of infinite cells. See here, this R and R combinedly considered to be one cell. Such type of infinite cells are connected like a ladder up to infinity. How to solve this kind of very complex problems? Observe this network. Here, R and R, two resistors, are considered to be one cell, and these two are also connected in the same way. Such kind of cells we have up to infinity. Okay, so to find equivalent resistance of this complete network from infinity to point A and B, we will solve using a simple method, sir. Consider the equivalent resistance between A and B as some X. What is X here? X is equivalent resistance of complete infinite circuit. Okay? See, this circuit is infinite long circuit. It consists of many cells, infinite cells. Okay? If we remove one of the cell, only one cell, this R and R form one cell, such kind of many cells we have. If we remove only one cell, means the point C and D up to C and D represent one cell. If we remove one cell and I am going to place this cell here, then the equivalent resistance of this infinite network will not change. Why, sir? The circuit consists of infinite cells, that's why removal of one cell doesn't change the equivalent resistance. That's why if we remove one of this cell and place it here, then the circuit appears like this. So here resistors are R and R. This removed cell is placed here, and these two are the points A and B. Okay. Now the equivalent resistance up to A and B is X. Okay. So up to A and B, total resistance is X. If you remove one cell placed here, then the equivalent resistance between C and D will also be X cell. Why? On removal of single cell, the equivalent resistance of infinite network will not change. If you remove and think up to point C and D, again this circuit is an infinite circuit, that's why infinity to point C and D is also having same resistance. So between C and D, what is the equivalent resistance? X. This X is appears to be connected in parallel with R, that's why C D to infinity complete resistance will become X. That X is in parallel with our R network, R resistance. Okay, so these two are in parallel combination. This complete R and X is connected in series with R. So after solving this one, you will get an equivalent resistance of complete network. Okay, so here R and X are connected in R, X, R in parallel. Okay, so the equivalent resistance of R and X is R into X by R plus X now. This is the equivalent resistance. R into X by R plus X is equivalent resistance. So these two resistors are replaced with R into X by R plus X, and this is in series with R. So I'm going to draw another diagram. This is R. The equivalent resistance from infinity to this point is represented with another resistor whose resistance is Rx by R plus X. This is connected between A and B. So the equivalent resistance between A and B again it remains same, which is X. Now R and X are in the series combination. So equivalent resistance between A and B is RAB. What is RAB? Equivalent resistance between A and B is RAB. From the diagram, the value of RAB is RAB, means equivalent resistance between A and B is RAB. It is the combination of two resistors, R and R into X by R plus X. These two are in series, that's why the equivalent resistance of series combination is R plus Rx by R plus X. So up to AB, the equivalent resistance is considered to be X, that's why take it as X is equal to, simplify this one, the denominator will become R plus X and this one will multiply the R, that's why R of R plus X plus Rx, and simplify it by sending this on RHS side, R plus X into X is equal to R square plus Rx plus Rx. This R is multiplied with these two, R square plus Rx plus Rx. So on RHS side also, it is Rx plus X square is equal to R square plus 2Rx. Rx plus Rx is 2Rx. Okay. Now we will simplify it as X square plus Rx. On LHS side we have, and RHS terms are also written on LHS. They will become minus 2Rx minus R square. If you simplify it, you will get X square minus Rx minus R square is equal to 0. This is like a quadratic equation. This is in the form of quadratic equation, and we are going to compare this equation with Ax square plus Bx plus C is equal to 0. Comparing X square minus Rx minus R square is equal to 0 in this, X is the equivalent resistance of this complete network. This is connected with compared with Ax square plus Bx plus C. Okay. So here A value is equal to 1. In the place of A we have 1, and B value is minus R and C is minus R square. Now what are the roots formula? What are the roots of this equation, sir? Roots of quadratic equation is X is equal to, unknown value X is equal to minus B plus or minus root over B square minus 4AC by 2A. You just substitute all these values and simplify it. You will get the equivalent resistance up to A and B. Let us solve our quadratic equation, roots for the quadratic equation, by substituting R, A, B, C values in this equation. Okay, here X is equal to, X is the unknown resistance. Our equivalent resistance between A and B is equal to minus B. B value is minus R. That's why minus of minus R plus R minus root over minus B plus R minus root over B square, means minus R whole square minus 4 into A value 1 and C value is minus R square. A value is 1 and C value is minus R square by 2 into A is again 1. We substituted all A, B, C values in this equation. So we will get X is equal to minus into minus plus R minus root over minus R square is R square minus into minus plus 4R square by 2. Okay, so X is equal to R plus R minus 4R square plus R square is 5R square by 2. So here R plus R minus, this one becomes root over 5 into R by 2. Okay, so finally what answer will get, sir? after taking this R as a common, okay, R common, 1 plus or minus root 5 by 2. Here two possibilities we have. 1 plus root 5 by 2 into R. One of the option is 1 plus root 5 by 2 into R, and second equivalent resistance we may get a 1 minus root 5 by 2 into R. Here if you solve this one, you will get a negative resistance. Generally negative resistance are not possible, that's why negative values are not possible, so only one root. This one is the perfect option for us. So what is the equivalent resistance between A and B? A and B equivalent resistance is 1 plus root 5 by 2 into R. Okay, this is the final answer. Okay, in this way an infinite network we can solve very easily. The method is very simple. Generally in infinite circuit there will be n number of or infinite number of cells. So if equivalent resistance from infinity to point A is X, okay, if it is considered to be X, then on removal of one cell also the equivalent resistance will be the X. Means this infinity to X is joined with the first one and we solve in this method. We will get one quadratic equation. The solution of the quadratic equation will be the result of our equivalent resistance up to A and B. Okay, in this way we can determine equivalent resistance. For example, in this question, if we have values like 1 ohm and 1 ohm resistance are given up to infinity, then simply you substitute 1 ohm here, then the final answer becomes 1 plus root 5 by 2 into 1 ohm, which is nothing but 1 plus root 5 by 2 ohm. In this way, if R, in the place of R we have a number, any constant number, then you just put the number here and you will get an answer for any question. Let us understand this method using one more example here. In this example, once you observe it, R and one more resistance, second resistance is 2R is connected here. As compared to previous example, there in the previous example here the resistance was R. Now 2R resistance is replaced between these two lines. Now we want to find equivalent resistance of this network, infinite network again. Again, the method is very simple, same. From infinity to the point A and B, this is infinite network now, from infinity to AB, the equivalent resistance is considered to be X. Okay? On removal of one cell, this is one unit cell. If you remove one cell here, and if you think up to here, up to this point, again, equivalent resistance from infinity to this point again remains same. Why? For infinite long network, on removal of one cell, the equivalent resistance will not change. That logic I am using. So equivalent resistance between C and D means you are going to cut one of the cell here and placed here. Now one of the cell from the infinite ladder network you are removing. Between AB and CD, one unit cell is there. Here you have R and 2R2 resistors. Equivalent resistance from infinity to AB is X. Okay. From infinity to CD also equivalent resistance is X. Again, infinite circuit is reduced into a simple network now. After this, only simplification or successive reduction is left, very simple method. So 2R and X are connected in parallel. That's why what is the equivalent resistance of these two? When two resistors R1 and R2s are connected in parallel combination, then equivalent resistance is R1 into R2 by R1 plus R2. R1 is 2R into R2 is X, 2R into X by 2R plus X. This is in series with R. Between A and B, you have two resistors. R, first one, 2Rx by 2R plus X. These two are in series combination. Now we are going to draw another diagram with R, and second resistance is 2R into X by 2R plus X. This is reduced as a successive reduction method. This thing we discussed in our previous classes only. Okay. So now between A and B, the equivalent resistance is again X. So RAB means equivalent resistance between A and B from this diagram is R plus 2Rx by 2R plus X. And from the infinite network circuit, this resistance is considered to be X now. So substituting RAB as X, on simplifying it, the denominator becomes 2R plus X, becomes the denominator, and this is multiplied with R of 2R plus X plus 2Rx. Okay, so 2R plus X is sent on to LHS side. So X into 2R plus X is equal to, now multiply this R with this term, so it becomes a 2R square plus XR plus 2Rx. Now X is multiplied with these two terms, so 2Rx plus X square is equal to 2R square plus 3Rx. 2Rx plus XR is equal to 3Rx. Now these two terms are sent on to LHS side. So the final equation becomes X square minus Rx minus 2R square is equal to 0. This equation is obtained from our infinite network. So this is a quadratic equation. Now we are going to compare this quadratic equation with our standard quadratic equation Ax square plus Bx plus C, as we did in the previous method. Now comparing our equations, A is equal to 1, B is equal to minus R, C value is minus 2R square. So what are the roots of this quadratic equation? Roots formula, X is equal to minus of B plus R minus root over B square minus 4AC by 2A. Now substituting A, B, C values in this quadratic equation, X is equal to minus of B value is minus R plus R minus root over B square is minus R whole square minus 4 into A1, and C is 2R square by 2 into A value again 1. So X is equal to minus of minus is plus R minus root over R square minus into minus plus 8R square. 4 to the 8R square by 2. Finally this one becomes R square plus 8R square is 9R square by 2. So R plus R minus root over 9R square is 3R by 2. So here again we have two options. If we take R common, then 1 plus R minus 3 by 2 into R. Two possibilities we have. One of the solution is 1 plus 3 into R by 2, which is 4R by 2. Final answer is 2R. One of the option. And second option is 1 minus 3 into R by 2. This is the negative answer. Negative resistance are not possible. That's why the equivalent resistance of this network X is equal to 2R is the final answer. Okay, X is equal to 2R is the final answer for this network.